we'll get started. And I'd like to thank Maton Automated Systems once again for sponsoring this morning's coffee break. Now, the next session, we have 3 speakers, all of whom are ICAO technical officers. Now, they will be providing more detailed information on some of the topics that I or Mr. Kramer mentioned briefly. Before we get started, I would just like to highlight the email address for submitting questions. We will be able to take some questions at the end of this session. So if you email your questions to plenary_1@icao.int. So if you just make note of that, and I'll give you a reminder later as well. So, we're going to start off with Mr. Mark Wunneberg. Mark is part of the RPAS team, helping me. He is the secretary of the UAS Advisory Group, as well as contributing extensively to the RPAS panel, and is the organizer of this event. So, if you all please would welcome Mr. Wunneberg.
Thank you, Leslie. Morning, everyone. And I guess the first thing is to thank you for braving the elements today and actually making it here in one piece. Hopefully, nobody had any slips or falls on the way. As Leslie mentioned, for myself, providing an update on the UAS Advisory Group. A little bit of background for those that aren't aware of it, as well as some of the activities this year that we have undertaken, and some of the products that we've managed to push out. A quick sort of summary of what we're looking at today. Again, the background we're going to discuss the DroneEnable 3 RFI process, so you're aware how the process works and how we come about the selections, especially for tomorrow, day 2, which is our RFI day. We'll talk about the UTM Framework Edition 1, UTM Edition 2, and then we'll talk about the toolkit a little bit, and very briefly on the subject of 1090 and ADSB with small UAS, which you'll hear about a little later this morning. So as a background, USAG was formed back in 2015. When it was seen that we needed a little bit more flexibility in the traditional processes that ICAO had, and how to keep up to the pace of the technology of what we were seeing coming down the line with regards to small UAS, with regards to UTM, things like that. Obviously, one of the or the 3 main items that the AG was intended to address was to share best practices. Right? Collect those best practices from the states, from industries, from academia, put them into one place so that other organizations and stakeholders could use those. Assist states with the development of guidance material to help with the UAS operations. You can see that this is almost the foundation or the starting point to the work that Leslie talked about today with the model regulations. First, we provided guidance material. Now we're providing something a little more solid in the way of model regulations. And then expediting the development of provisions used to regulate UAS in different aspects of the operation itself. 39th Assembly, which was held 3 years ago, really was the start, and it was a request that ICAO develop this global baseline for UAS provisions and guidance material so that this organization could start moving forward, and that was really the foundation of the USAG sort of version 2 moving forward with this activity. And that includes the work that's going on currently with the UTM activity. That's the major focus of what we're doing right now. Right now in the AG, we have states, we have operators, we have researchers, we have academia, all participating so that we're getting a better, more rounded model and understanding of what's going on in the industry. It's not just states or single organizations. We're getting input from a variety of sources. I will say to an extent we also try to make sure we handpick those particular people that participate so that we have contributors and people that are producing the work that needs to come out of the session. As you heard earlier as well from a couple of the other speeches, since the last DroneEnable in Chengdu, we had the Air Navigation Conference and the 40th Assembly, and it was good to see that both of those activities endorsed the work that's going on by the USAG and encouraged additional work to continue. So for DroneEnable 3, for the RFI process, we were actually privileged this year that we had a little bit more time than we had in past years, so that actually I think has created or allowed us to create a stronger RFI session for tomorrow, which you'll see on your programs. A bit step back as to what was the purpose, right? The purpose of the RFI was how do we get those inputs from states, from operators, from the key stakeholders on the problem statements that we're seeing out there, in this case on UTM. Started obviously 3 years ago at 2017 DroneEnable or DroneEnable 1, where we focused on certain items and we've progressed. And as we go through symposia such as this, the discussions that we get out of those symposia help us figure out what are the problem statements for next year. You know, the term you often hear is which is the closest alligator to the boat, right? Because that's what we want to focus on, right? It doesn't do much good if the advisory group is sitting there looking at things, yeah, this is something really cool, but we're not going to solve this for 20 years. We need to start looking at the things that are sort of really close and to the forefront. So those are the sort of approach we're taking. I think one of our advisory group members mentioned the term near-term goals with long-term aspirations. Right? We want to get those near-term goals taken care of. So what about this year's RFI Summary? We had 42 papers submitted, a little lower than we had have hoped compared to previous years. We had 4 problem statements. We thought we might get a little bit more. Based on those, the advisory group actually went through all 42 of those papers. We had a survey, a standard questionnaire that the advisory group had to go through and assess each one of those papers, and then we scored them on those scores, and the top 19 that came out of those were selected as presenters for tomorrow's RFI sessions. That being said, there's another chunk of papers that aren't being presented. Those just don't get tossed away. If there's good material in there and there's good nuggets and interesting concepts, the advisory group uses that material as well as we continue moving forward with our other additional documents. We did find some of the problem statements were better addressed than others. One, it could have, and we try to figure out why each year. One could be that perhaps these problem statements were a little too far looking, that the industry wasn't quite ready to hit those yet, and the other could be that we're not necessarily formulating the questions correctly, and you'll see that tomorrow afternoon with one of the sessions where we're looking at the situations of emergency and contingency operations. Majority of the papers we received were on emergency, and it was supposed to be emergency contingency operations of UTM. Most of the papers we received were what if a drone in the UTM fails, where we were looking at what if the UTM itself fails, right? So we have to be a little bit clearer on some of the information that we get out. This year, I think the other difference which we did was we assigned technical leads because we had the time for each of those 4 problem statements. And these technical leads, their job was really to orchestrate the story that comes into this DroneEnable from those presenters. We wanted to make sure it's a cohesive story and it was planned out well. And I think that bore some good fruit, and I think again you'll see that tomorrow. So what about the products? What's coming out of it? At Chengdu last year we gave an update on the UTM framework and what it was going to contain. I'm happy to say that that framework has been published. We published that in April of this year, and basically it's a framework of those core capabilities that a typical UTM system would have. This is not the answer. This states if you want to deploy a capability of UTM, here's the things you should start looking at and things you need to start considering. again, it's a requirements and considerations kind of document. The important thing too is, as I mentioned previously, it's not a technical solutions document, but instead it's sort of a common agreement that remains consistent with the principles of the convention on how to move forward with a UTM system. So what were some of the objectives? Foster a common framework, harmonization of those core principles. Right? What does a UTM need to be? What does it need to look like? What does it need to do? Number two, and which is the top priority, obviously, is maintain safety, and with that, minimize the disruption to the existing aviators that are out there today. Support technological developments in UTM and UAS. Right? What does that mean? Don't be prescriptive. Again, these are recommendations, things that people need to start thinking about. Provide safety-focused recommendations on the development of the systems, address the security and environmental risks, as well as enable stakeholders to grow safely and effectively. So the overall aim of Edition 1 was, because that really set the entire framework of the UTM framework, put some principles and some building blocks out there for people to consider, discuss the services to be provided by a UTM system, what were the gaps, issues, and challenges, and some complementary activities. So we might not have all the answers yet, but there's a whole list of things that states can already start doing to enable and to facilitate the implementation of UTM before UTM shows up. So we focused on those. And what will be interesting when we talk about Edition 2 here shortly is those gaps, issues, and challenges. As we're moving forward, we actually got to remove some of those because we provided some recommendation and guidance in some additional material in Edition 2 of the framework. Okay, Edition 2. So the sort of focus of last year's RFI and the information going into Edition 2 had to do with that integration between ATM and UTM. As we start looking at UTM, it's going to start getting closer to those boundaries of ATM. So the two main issues we looked at were ATM-UTM boundaries and transitions between those. What are some of the challenges? What are some of the guidance we could put out there? As well as what was the essential information exchange required if aircraft were going to be either close to that boundary or actually transitioning through that. And we looked at it both directions. What if a UAS wants to go into airspace traditionally managed by an ATM, or vice versa, we have the life flight helicopter that has to go through UTM airspace into the children's hospital or something. So we looked both directions on that. Happy to say that we published this document on the 1st of November. It is now up on the ICAO Unmanned Aviation website for your viewing. And we also addressed how we worked in the AG this year, which I think allowed us to accomplish the task faster. And we're going to do the same thing for Edition 3, which you'll hear about a little bit later as we move forward. Okay, so ICAO Toolkit. As Leslie said, I'm sort of the keeper of the toolkit. For those that aren't aware, what is the purpose of the toolkit? It's really to provide states and stakeholders with some high-level guidance material on the safe operation and the regulation of UAS. Right? It has certain topics that are specifically addressed, as you see on the right, with regards to regulating, training, authorization. The other tool, which is very handy, is there's a drop-down menu, and on that menu are the regulations. I haven't checked recently, but I think it's at least 35 different states, the regulations that they use for their UAS. So if a state is looking at how am I going to regulate this aspect or that aspect, they can actually go in to see how other states are doing that. And that also feeds into, again, the model regulations that Leslie talked about this morning. Okay, so the first toolkit was published about 3 years ago. We have to make sure it remains current and relevant. So as a task this year, the advisory group decided to go through an update of that. We would encourage everybody in the room to take a look at that toolkit. If you have any recommendations on things that we can do to improve it further, please send those in. There is an email address on the website itself that you can send those to. Some of the things we looked at this year, we needed a better description or discussion about controlled and uncontrolled airspace and UAS operations, address some of the new advancements out there, UTM, UAM, urban air mobility, thinking about futures, as well as we're looking at including some planning tools that states are putting up there, before you fly apps, those kind of maps, things that help UAS operators in conducting safe operations. So currently we have, I believe it's 5 that we're going to be placing on the website shortly. If there are, again, once you look at them, if you see ones where there's good tools out there that people can use as part of their planning processes, let us know and we can assign those links and attach them to the drop-down menu in the same way as we have with the national regulations. Okay, 1090 ESB letter. As a group of small UAS and UTM subject matter experts, the AG was asked to comment on this state letter, which we did. We provided some comments back. You'll hear more about the state letter on the next presentation. So where are we going now? Next activities, almost looks like a bit like Groundhog Day, is that we're looking at doing the same thing again, but in the next iteration. UTM Framework Edition 3, we want to develop that. We're going to develop the DroneEnable 4 problem statements. Again, your contributions are going to help into that, part of the discussions tomorrow as those progress. Once we have those, then we'll draft the RFI for the DroneEnable 4 and go through the same submission assessment process. For the AG, there's a look at our meetings. We're going to do a meeting immediately after this on Friday so that the group itself can coalesce on what were those big points we learned from these sessions, from the discussions that you'll be part of, so that we can put those into Framework Edition 3 next year. And we want to do that while it's fresh in everybody's mind. Then we'll hold 3 face-to-face meetings next year with the DroneEnable 4 coming in the fall. With that, I say thank you. Quick summary of what the AG has done this year, and we will take questions once we've all presented. Thanks very much.
All right, thank you very much, Mark. Next, we will hear from Mr. Vaughn Mayola. Vaughn is the Secretary of the Communications Panel here at ICAO and has been steeped in aviation communications for a few decades. Not to age him in any way, but he has extensive background in aviation communications. So, Vaughn, please.
Yes, thank you, Leslie, and good morning, ladies and gentlemen, and thank you too for the opportunity to talk to you about what I consider to be a fairly significant subject today. As the previous speaker mentioned, we're looking at the subject of 1090 megahertz, which is used for a number of modern surveillance facilities, and we're also looking at the 24-bit aircraft address, which is covered by ICAO policies. That too is used for surveillance and communications. So they're both vital, essential to modern manned aviation. Now, despite the lengthy title of this presentation, I could sum it up in one word: scarcity. Now, I know that the exploitation of unmanned aircraft for commercial aviation is an area just bursting with opportunity. So it sounds like I've come here to, as the Americans would say, rain on your parade. No, I haven't. And hopefully this presentation will end on an optimistic note. So let's get on with it. The ICAO Surveillance Panel has been looking at the possibility of accommodating unmanned aircraft with today's surveillance systems. And those two surveillance systems depend on two essential commodities. One is the frequency pair of 1030 and 1090 megahertz. The other is the 24-bit aircraft addressing scheme. And I'll just take a moment to explain why those are important to you. If you look at the list there in the first column, you see that we have at least 3 existing, or actually 5 if you want to be pedantic, modern surveillance systems. Now, the first one, secondary surveillance radar. Well, that actually originated in the 1950s. So when I say modern surveillance systems, I'm using the word very loosely. That started off operation using 1090 megahertz. That's how the aircraft makes itself known to the surveillance facilities on the ground. It identifies itself using the 24-bit ICAO address, which has been standardised for many decades. Now, that one system that's in use globally that uses just 2 single frequencies has served us well. So the concept was sound way back in the 1950s when it was developed, and it's still working for us today. So well, in fact, that we've grafted lots of other capability onto that. For example, we have TCAS and ACAS, which use exactly the same hardware on the aircraft. Sure, there's different software functionality and there's a different certification process behind it, but it is the transponder on the aircraft that supports these functions. That's been modified even further, and today we have ADS-B, and they're all great developments, but they all add loading to those frequencies. And remember, this is a global system. Every aircraft in the world, every manned aircraft in commercial operations, supports secondary surveillance radar, multilateration, TCAS and ADS-B using those 2 frequencies. The other thing too is that we've actually over the years added extra information to the signals that are sent. So we're fighting a little bit of a battle on many fronts. And the surveillance panel, the ICAO surveillance panel, is somewhat preoccupied with just keeping the system optimised. They're constantly working on incremental changes to squeeze a bit more out of those 2 frequencies. Now, it's not necessarily a problem covering the globe, but you look at high-density airspace like Western Europe, the Northeast Corridor in the US, and emerging areas, say China. Air transport's growing in leaps and bounds there. There are problems, and they've been solved with little tweaks to the system over time. Now, I won't go into what they are, that's beyond the scope of this discussion. But also, too, people are looking at other applications, other uses for this system. Okay, enough on that. Let's talk about the 24-bit address. As I say, that's been around for many decades. But it, too, is a finite, limited resource. When the original provisions were defined, yeah, they expected it would have a reasonable service life, and they did make some wise decisions. But if we think about some of the predictions that have been made today for the population of unmanned aircraft that we can expect, we're talking millions and millions. Neither system was designed to support that. So what would happen if we did accommodate unmanned aircraft using these systems, these modern systems as I called them? Well, we'd have 2 big problems. We'd have an exponential increase in the safety risk due to congestion on that 1090 megahertz frequency being used for the surveillance system. And not only that, we would deplete the pool of 24-bit addresses. That's happened in other areas. Cell call, for example. The same cell call code is often applied to different aircraft, and all that does is create confusion on the ground and in the cockpit. Hence, there's a safety risk. Let's not make that mistake again. I'll just talk a little bit more about the consequences here. There was a study done, or 2 studies in fact, one by MITRE in the US and another which built on that and was done by NASA. And I'd consider them both very creditable sources. They looked at the impact of large numbers of unmanned aircraft on the ground-based surveillance systems. They made an assumption. You'd have, in a busy area, in a city, let's say, or a heavily populated region, you could expect to see 1 unmanned aircraft for every 2 square kilometres, or 1 unmanned aircraft per square mile. Now, most of these would be operating at a low level, below 500 feet. But in typical high-density terminal airspace, you could expect to find 760 of these aircraft operating within the range of the secondary surveillance radar at the airports. You also have to remember too that many of these airports are located close, can't even say it, excuse me, quite close to one another. On top of that, we have other facilities, ADSB and so forth. They all have a similar range. And now they're being deluged by 760 additional aircraft. The net effect of that is these aircraft flying at a low level could actually blind the surveillance systems to the existence of manned aircraft operating at altitude. That does sound, I think you'd all agree with me that that is a serious problem. Now, it could be argued that we have plenty of 24-bit addresses today to give out. And I think we do, based on manned aircraft alone. But if we look at some of these projections for the population of unmanned aircraft in the future, we're looking at tens of millions of the things. We don't have enough addresses for them. And I did mention what the problem there would be. You can't just simply reuse addresses for multiple aircraft. The SARPs, the provisions, all say it must be one address, one aircraft, or else you've got chaos. So what's the solution? Well, the fact of the matter is that there will be unmanned aircraft that fly into controlled airspace, and they will have to interoperate with manned aircraft. So there's no choice but to let those people use 1090 megahertz, 24-bit addresses and so forth. Now we do need to look at the impact of that, but that does look doable, let's say, to just use a colloquial phrase. So a state letter has gone out. It may have reached some of you already, and it basically is an early indication of changes that are going to be made to the guidance material in document 9924. That's the Aeronautical Surveillance Manual. I won't read those words to you, but I will display them and let you read them yourself. But the key point here is that there'll be an obligation on states to analyse the impact of supporting unmanned aircraft in non-segregated airspace. And if it's found that those unmanned aircraft can be supported, let it be. Let's let it happen. If we jump ahead to another proposed change to the guidance material, again, we need to look at the impact of such operations and maybe put a limit on them. And this is important, and this will be a job for the regulators. Well, at least that's what's being proposed. And similarly, the same provisions are being proposed for the allocation of 24-bit addresses. But do remember, what's being proposed here is that we allow those aircraft operating in controlled airspace to use the existing surveillance facilities. So what do the others do? What about all those little ones flying below 500 feet? What do we do with them? I've basically told you there would be a safety risk to allow them to use 1090 megahertz, for example. Well, I think this represents an opportunity to start with a clean slate and come up with some new system. I mean, we've basically exhausted the physical capability of the existing systems, so the challenge is there. Let's come up with something that's appropriate for unmanned aircraft, something that's got a lifetime of another 3, 4 or 5 decades, hopefully, and see what we can do. Technology has advanced significantly since the 1950s, when SSR was developed. And we can ease the transition though. Yes, we can accommodate unmanned aircraft in controlled airspace, but the ones that are not in controlled airspace, let's not turn them into a source of interference. Let's give them something brand new to work with, using modern, up-to-date, and this time I do mean modern, technology. And I'll end on an optimistic note. If we can come up with something that works for a large population of aircraft, and it's demonstrably better, which I think it will be, well, great. Let's apply that to manned aircraft as well in the future, and we'll have a common system. So in fact, what I'm suggesting is the work that the unmanned aircraft community does could end up coming full circle and affecting what happens with manned aircraft. That to me is another area bursting with opportunity. So I'll stop there and I'll finish with just 2 words. Please consider. Thank you.
Thank you, Vaughn. And I just wanted to point out that the state letter that has been spoken about it was issued on Friday. It is posted on ICAO.net, but since most of you probably do not have access to that website, it is also on our event website, so the DroneEnable website. And I think we'll try and also get it onto the app as soon as we can. It's published in all 6 ICAO languages, so please do go find it on the website and have a read, because we need this industry to come up with something new. So next, I'd like to introduce Mr. David Scorer. David is also a technical officer here at ICAO in the operational safety section, where he handles various activities, including much of the work leading to the aircraft registry network, the supporting requirements that underlie that. So David, please.
Thank you, Leslie, and good morning, everybody. So this presentation today is on the concept, as we're calling it, of a network, an interconnected network of aircraft registries. We've conveniently called it the ARN, the Aircraft Registry Network, for now. So today I'm going to bring you up to speed with where we are with our thinking about this concept, because you might have seen it mentioned at previous DroneEnable events. And it's also going to tee up some big picture thinking and some questions for you to consider in the coming few days. So I'll start with an overview of what I'm going to talk about. I'm going to begin with the existing ICAO framework and how that applies to registrations. I'll talk about what states need in the current situation, although I'm sure you're all well aware of that anyway. Then I'll introduce this concept of the ARN itself. And then this year we've been working on 3 areas, and I'll touch on each of those individually: the unique manufacturer codes, a common taxonomy system, and some customized web applications that we've developed in-house here. And as I get towards the end of the presentation, I'm going to touch on the value features, the benefits that we can really see of a globally connected network of registrations, and finish with the next steps and the feedback we're looking for from states and industry. So, starting with the existing framework at ICAO, I'll take you back to the Chicago Convention, signed in 1944. Within there, you will find articles for nationality and registration, 17 and 18, which say that an aircraft shall have the nationality of the state in which it's registered, and it can only be registered in one state. Standards for this are defined in Annex 7, appropriately titled Aircraft Nationality and Registration Marks. Why is this important? Well, the wider ICAO framework is built on the foundation of these registration principles. So we're talking pilot licensing, surveillance, airworthiness, which are certification standards, accident investigation, and. And Leslie touched on a number of the elements of work earlier on this morning that was going on there. What we're asking here is how can this existing framework be leveraged to benefit UA operations and their business models when it comes to registration. So what do states need? As I said, I'm sure you're all very aware, increasing number of drone operations means it's increasingly difficult to maintain satisfactory safety oversight on the state's behalf. 2 main areas, of course, UTM, sharing existing airspace, and law enforcement, taking enforcement actions when necessary. I don't need to dive into them. What I will refresh us on is what the current situation is when it comes to registry systems. Many states don't have one at all. If we look across the 193 member states, Those that do, they have often been developed independently, so there's a lack of consistency, and they certainly don't talk to each other if they've been developed in independent silos. And then, of course, because of that lack of connection, there's no ability to maintain oversight across borders, and certainly no possibility of identifying foreign operators, drones and operators that might come to their shores. So what we believe is that there's a collective recognition that this must start with registration in some capacity. And that's where the concept of the ARN comes in, which is essentially a network of connected aircraft registries from the member states. We can make it applicable to both manned and unmanned aircraft and solve a number of challenges we have in the manned aircraft world as well. And this network would facilitate the exchange of key information on each individual aircraft and their operators. Importantly, to enable these valuable interstate operability services that we see to be developed around access to that data. So we really see this connected network of compatible registries, and I'll come back to what I might mean by compatible shortly, as a way to begin to address some of the challenges that I've just mentioned and that you all are very familiar with. So diving into the three areas that we've been working on this year at ICAO in the ops section, manufacturer codes, a common taxonomy, and customized web-based registries. So I'll deal with each of those in turn. Starting with the manufacturer codes, as I'm sure you're aware, in September this year, CTA Standard 2063 for serial numbers was published, which covers the elements and characteristics of a serial number for small US. And I'm sure you know as well that the ASTM standard, remote ID standard, points to this. I'll just highlight some elements of text from that document. It defines how a serial number should be comprised, and within that composition you'll see a 4-character manufacturer code. That document also states that ICAO is now responsible for assigning that manufacturer code. How are we doing this? Well, this is where we're leveraging the existing framework. We're doing it through an existing system and an existing process, document 8643, aircraft type designators. You don't need to read all the text, but just understand, if you're not familiar with that document, that it really covers common names of manufacturers, types, designators, models, model numbers, etc. So we already have a process in place, and we're expanding it to include UA manufacturers and the 4-character manufacturer code. So that's already started. If you need a code already, you can go to the website. The website's on the screen there, or you can access it via the ICAO main website and follow the directions on there. And the paper version of this manual will be published in April this coming year. So that's one area. The second area where we're leveraging an existing process and system is the common taxonomy. Now, I need to explain CICTT because it is a bit of a mouthful, unfortunately. The C stands for CAST, which is the Commercial Aviation Safety Team, which is a government industry partnership looking at a data-driven strategy to reduce commercial aviation fatality risk. You can go to their website and read more about them, should you wish. They are the C. The I is, of course, ICAO, and together they have formed the Common Taxonomy team. What do they do? Well, they are tasked with developing common taxonomies and definitions for aviation reporting systems. So things like make, manufacturer, model, but also a full range of fields, information fields. Again, you can navigate to their own website via the ICAO public website, should you wish to know more. I'm just going to highlight a couple of points here that you can't see in that small text. They're doing this to establish this standard industry language, and that helps because it improves the quality of information management and then data communication when you've got systems that need to be connected. So why is this important for UA registration? Well, hopefully it starts to become fairly evident. Let's consider it from the point of view of an applicant registering a drone in their state registration system. Here's one I made earlier for the state of Futureland, but this really applies to any country. At some point, as an applicant, I'm going to need to enter the details of the aircraft or drone. Now you can see here that these fields we have constrained to drop-down lists, which means I have to select them from a predefined list of manufacturers and then model and series. The feedback we've had from states is that if you leave these sorts of fields open to free text fields, it can result in some sort of chaos with multiple variations of data for the same air vehicle, capital letters, lowercase, hyphens, numbers, spaces, and. So we really want to try and constrain the selection to a managed list so that subsequent data management and intercommunication works smoother. Where does that data come from? Where do those lists come from? Well, the common taxonomy. So we're looking at leveraging the existing system, the CICTT platform that I told you about, and expanding it to address UA as well. That's a big deal and quite a complex technical solution, so I'm happy to report that we have the technical support of Ministry of Land, Infrastructure and Transport from South Korea to help us with development of this system, or expansion of the current system rather. And what will it do? Well, of course, it will provide this managed data set of UA, make, model, and series so that all registries, all state registries that connect to it will be able to present these predetermined lists for selection by an applicant. We want it to do more, of course, and it can do more. We can't hold up the registration process, so the applicant needs to proceed, even if their vehicle is not available for selection, so there needs to be a method of informing the taxonomy team so that it can be formally incorporated. And we'd like it if manufacturers were able to proactively inform the taxonomy team in advance of the release of new models so that they can be formally incorporated before the product hits the market maybe, so that they're already there for selection when the first person or organization comes to register it in their state. How does this impact or relate to AON? Well, of course, this is where I come back to compliance. All AON compliant registries must really store data in accordance with the common taxonomy. And it's a really fundamental building block foundation if we're going to ensure consistency of the data communication of an interconnected system and all the value features that we can implement on top of that interconnectivity. There are some challenges to overcome, of course, and here is where really we're reaching out to the room and the expertise to help us with this. How do we establish a technical interface with registries that maybe already exist? Do we create an API? Do we open source the code and allow states to implement it themselves, or are there other solutions there? And of course, we need to transition existing data sets into this common taxonomy format. So this is an area where we're really looking to industry in the room here for support and input as to how we can proceed. So the third element that we've been working on here is something that you might have seen previously if you were at the last DroneEnable event. It's a custom web application, which we have developed in-house at ICAO. It's standalone. It covers the full end-to-end process of registration and can be adapted for big metal aircraft or UA or both as a state may wish. And it can be adopted by any state right now at zero cost for them to manage their full day-to-day registration tasks. Why might they want to do that? Well, hopefully it goes without saying, but of course it's a turnkey solution to save money on development of their own electronic platform. Implementing an electronic solution will save them time and cost, inefficiencies of a paper-based system, which many states have, certainly for big metal aircraft. We've developed it, of course, so that it's already compliant with this common taxonomy I talked about, and so any future services and a registry network that's developed, this will already be able to slot in and benefit from those features. And then one final element, which takes us all the way back full circle to the Chicago Convention. There's another article there, Article 21, which requests states to provide pertinent details of registered aircraft information to ICAO and to make it available to member states. Well, this would feature automatic provision so that it's a job done for the state without any additional effort. So that system's a bit more mature now. You might have seen a demo, early stage demo at the previous event, and so we've been working on that this year as well. So now as I start to get towards the end, I'm going to touch on very high level some of the value features of having a globally connected system that I've talked about, and the benefits of registering in the first place, and then the features that we can build and develop on top of that registration and access to that data. So this is a top level, and there's going to be more details coming on this in the next couple of days. Statistical information, of course, that's a very simple one, global statistical information. Facilitating cross-border transfers, this is something that currently applies primarily to big metal aircraft, where it's deregistered in one state and before it's registered in another state, well, it's referred to as a stateless aircraft, and that can present some challenges from an airworthiness perspective. Can we eliminate that problem by having an interconnected system of registries where it comes off one and onto another instantaneously? Specifically UA now, delegated functionality. Maybe I am the registered owner in my state, but I want to delegate operations to somebody else. Maybe that operator could be registered in the system as well, and I could formally transfer custody and control. And then features for international UA operations. This is fairly evident, I guess. I'm registered in one state, and I've registered my drone, I'm the owner, and I want to go and operate in another state for personal holiday reasons or for business. And I'm sure there are many others, but these are the kind of features that we can build on top of a connected registry system. And the benefits that they bring, these kind of value benefits for day-to-day UA operations, well, the state can maintain oversight of the operators, not just the registered owner, but maybe the operators are in the system as well, so the state knows who they need to target should they need to. It brings a bit of comfort for the owners themselves. If they have delegated custody and control, they know they're not the ones that are going to be held responsible should there be an infraction, and that the state can go after the operator who currently has custody and control. Identifying foreign registered drones. If a connected registry provides access to what we could term an international data set, it would make it easy for a state to maybe identify that the drone they're looking at has been registered in another state and not their own. Currently, that functionality just doesn't exist. Maybe a state can go further. They can define specific requirements like a permit system, so prior permission is required to come and operate it in their state. Maybe they want to define or request a local address, like a hotel address, whilst the operator is in country. And if that process was implemented, then operators could be more informed of the specific rules and regulations that might exist in that state if they were to be taken through that process, even if they're registered in their own state, they want to go and operate it in another, and they go through this permit process. And of course, I'm sure there are many more that you're all very familiar with, and these will all come out in the coming days, as will more details and some excellent presentations and some demonstrations to come, starting with the Trust Framework team after lunch, and then you can look forward to a good demonstration towards the end of the day on Wednesday, which will really take this concept and expand on it and show how it might really work on a day-to-day basis. So to sum up on the next steps, what we're looking for, really how can ICAO help facilitate this development of an interconnected registry network? What's the appetite for it, and how can we roll it out? How can industry support this common taxonomy framework that I talked about? We see it as a fundamental building block of an interconnected system, so we're really looking for support on how this can be developed and implemented. What else can we do to support UA registration initiatives? What else are we not thinking about? And then finally, for states, any states that might be in the room, if you are interested in trialing our custom web application, then we'd love to hear from you. There's a direct email address on the screen there, and of course you can reach out to us at any time through the RPAS or DroneEnable team. That's it from me. Thank you very much.
All right, thank you, David. So, 3 very good briefings on work that is underway here at ICAO, and I'd really like to see if there are any questions from the audience. I have received a couple via email, and just as a reminder, the email address is plenary_1@icao.int. But to start off, David, I have a question about are the ASTM e-identification standards going to be the ICAO standard? We've got microphones on the table there. So how is the relationship between what ASTM has done versus the ICAO standards, if you could explain?
So the standards relating to UA with respect to flight operations, airworthiness, that sort of thing, we haven't, to my knowledge, incorporated the ASTM standard into any text within ICAO standard, and I think that's being discussed on your work program within RPAS, yes, but I do believe we're going to be pointing to it in the guidance material.
Right, I also have a question here for Vaughn. You mentioned, let's give them something brand new. Would you like to elaborate on what would be brand new and what kind of expectation, a notional expectation or example?
Okay, well, if you read the technical press these days, there are all sorts of miniaturized systems that don't have the bulk and the weight of the traditional systems. There are systems that are modular, and I suspect that they would have the certification effort required to use those would be less. Something like that could be better. And also, too, we'd be looking at, say, some sort of multi-mode system, because when we're looking at unmanned aircraft, they have to not benefit from surveillance, but they have to perform detect and avoid. So they've got to not just avoid other airborne vehicles, they have to avoid obstacles as well. And there are all sorts of technologies that could be used there. LiDAR, this sort of thing. And there have been incredible developments made in recent years towards having very, well, how would I put it? We're looking at another wave of miniaturization beyond what we saw with the computer chip. We're seeing whole systems being miniaturized. Perhaps we could exploit that. But again, I'm just relying on my imagination, and and a lot of optimism there. I really don't have the complete answer, but I would say we should try and exploit technological developments that have occurred in other areas. There are lots of startup companies doing experimental work on systems. Let's try and break out of the standard industry focus that we have with the traditional suppliers and try and vacuum up, if you will, the developments being undertaken by some of the more innovative companies. Thank you.
All right, and if there are any more questions that you'd like to submit, please do so. I'd like to just add on to that question and Vaughn's response and say that much of the purpose of DroneEnable, so this event, is to raise awareness of these various issues. It's to bring forward information from innovators. It's also, we're looking at having innovators hear what the new problems are so that you can go out and start doing the development work. There's a lot of research and development that needs to be done in order to find solutions to these new problems as they are identified. So we do need to have that exchange of information, innovators hearing what the problems are, and at the same time, innovators telling us what they are already developing that can have a dramatic effect on aviation as a whole, not just for unmanned, but also for manned aviation. A lot of material will carry across. So, okay, I gave enough time. We do have a couple more questions here. We'll see what they are. So, for Mark, does the world see UTM as a new chapter in the book called ATM, or does it see UTM as a new book?
Yes. Yes. In simple terms, yes. Both.
There you go.
It depends on which direction you're looking. Some are looking at it as a new standalone type system, and some countries, organizations, stakeholders are looking at something that might be part of an ATM or an existing ATM or ATS system. Again, part of the key aspects of the frameworks is we didn't say it has to be this one or it has to be that one. It allows states, it allows manufacturers, allows industries to solve that problem however they deem it best to be solved. So in the end, it could be part of the existing ATM, ATS system, or it could be its own book standing alone. It could also depend on the use case. Perhaps if it's in a very congested airspace, maybe it has to be connected to the ATS because there's that linkage, but perhaps if it's a remote area where there's lots of activities going up, could be a book all by itself. So I think the answer depends on the use case, and it depends on the operations that are going on in that area.
And a related question about helicopter pilots who are at more significant risk, generally speaking, than many others from encountering drones, because helicopters are more often operating at low altitude in areas where drones might be located. But I would extend that as well to our general aviation colleagues who often are also operating at low altitudes. And how do we prioritize traffic within a UTM system between manned aircraft that happen to be operating at low altitude for good reasons versus unmanned aircraft that are operating there?
So that question has about 3 different questions inside it. So I guess I'll go forward I'll try to address them in order. One important issue is education, not just of the UAS industry, but of the helicopter folks and of the GA industry. There was an example that some of you may have heard in DroneEnable 2 in Chengdu of a particular system that was developed, but the GA and the helicopter industry knew nothing about it. So they're flying in a UTM environment without knowing that there's UTM approvals being done in that same environment. Right? So there's an education, and there's perhaps some technology that would also allow those kind of information to get passed not only to the UAS, but also to GA or to helicopters operating in that environment. So I think that's part of the answer. The other answer, which is about sort of the prioritization, I think goes back to the basic fundamentals of aviation, of equal and fair access to everybody, right? Doesn't mean that the prioritization issue doesn't have to still be focused on, i.e. if there's a life flight helicopter going in an emergency situation, they have priority. That doesn't change in a UTM environment. It's still a priority. That being said, we also can't have one particular organization hogging all the routes and the airspace in a situation under UTM. Again, it needs to be fair and equal access, and those are some of the fundamentals that are covered as part of the UTM framework. I hope that answered the question for whoever answered it.
All right, thank you. And a quick one for David. In order to register in the ARN, a manufacturer is needed. But what about all of the home-built or privately built unmanned aircraft that need to be registered as well? How does that work?
That's a very good point, and something we have considered in a lot of our chats about what shape this system would take. It wasn't in the slides, but it would need to be something that we considered how somebody could register a home build, what element of that air vehicle they would register within the system, and whether or not those vehicles started to be incorporated within this wider taxonomy, and how exactly we do that. It's a very good point. We don't have the answer right now, but it's definitely on our radar for something we'd need to address.
Good, and I'm just going to do one last quick one for Vaughn, because we are up at our lunch break. So, Vaughn, are we looking at mitigating the ADS-B problem, or are we looking at alternate solutions, such as UAT?
We're definitely looking at alternate solutions for those aircraft that will not be in controlled airspace. And as I said, I do hope that those alternate solutions lead to a common global solution in the future. So yes, alternate solutions, correct.
All right, thank you. So everybody, if you would please thank our ICAO technical officers. And if you would all please stay seated, we will have well, except for you three, you may all depart the stage. Oh, wait, I'm sorry, wait, no, Mark, we have to do, there's a group photo. Actually, here, if you three want to stand while I start into this next. We will get the system running smoothly here shortly. But I would like to invite Mr. Mark Keller. Keller, close enough. I tried, I'm sorry. The CEO of Unifly, to provide a short briefing. Unifly is sponsoring the lunch today, and Mark would like to come explain a little about Unifly. So please.
For good order, the name is pronounced Kegelaars, but no one is able to pronounce it correctly. Okay. I'd like to share you a little story. March 17 of the year 2016 is a day that I will never forget. Because that day I had a meeting with Mrs. Peggy de Vestel. Peggy was and still is the Chief Operating Officer of the ANSP in Belgium, called SKYS. Now, I had known Peggy for several years because she had been the regional manager of SKYS in the International Airport of Antwerp, where I had done a lot of my flying as a flight instructor. During that meeting, I told Peggy that I just had left my job at the Flights Academy, and I had joined a new and very exciting young company called Unifly. I explained how we had a vision that drones would start to fill up the skies and would start to be used for many types of applications, such as infrastructure inspections, urgent delivery of drones, of goods, precision culture, and so on and so forth. We expected that drones would revolutionize and disrupt entire industries. Peggy and I, well, mostly I, talked about the need for a new type of management system which would be used to manage the lower airspace and manage drone traffic, knowing that the drone users and other stakeholders would know very little about aviation. I explained how Unifly had been working on a cloud-based software to make it possible to integrate drones in the manned airspace, an application that even at that time was already SWIM compliant, and as such able to exchange information with the existing ATM infrastructure. The meeting itself was actually quite pleasant and lasted for more than an hour and a half. And at the end of the meeting, I asked Peggy, what do you think? Well, Mark, she said, thank you for the explanation, but we don't need this. We don't see any drones in our airspace. Drones are toys. We don't expect this to become an issue. We have other priorities to deal with. I can tell you that was a slap in my face, and that's why I remember that date. It was not the reaction that I anticipated or had hoped for. But I had several meetings like that that year. The general thinking about drones in the world of manned aviation in 2016 was quite negative. People were either totally indifferent or even quite hostile towards drones. But then things started to change. In 2016 already, we saw the first results of the NASA UTM project, a research program that ultimately designed a fully federated approach to UTM and tested the level of completeness of the technologies needed to build such a system. And over the years, we witnessed the announcement and the launch of the Lance concept in the US, the initiatives of METI, JAXA, and Japan UTM in Japan. We saw the launch of the U-Space concept in Europe in the Helsinki Declaration of 2017, and that's just 2 years ago. We saw the efforts of ICAO with the DroneEnable 1 and 2 conferences. We witnessed a wide range of demonstration activities all over the world, including UPP and IPP programs in the US, and the U-Space research and demonstration projects in Europe. We've seen growing interest in the subject of UTM during international conferences. We have heard about the ICAO's guiding material, and we've seen now that there's a new drone legislation has been voted on June 11, 2019 in Europe. And even the ICAO General Assembly is now urging member states to start looking at UTM for the integration of drones in their airspace. During all these years, Unifly continued to develop its product in line with the results of the various research programs and with the requirements expressed by airspace managers, drone users, and also local authorities. We did participate in many of the international programs. We are a major contributor to the creation of the European U-Space construct through our participation in 10 of the research and demonstration efforts. Lately, our software has been used as a part of urban aerial mobility demonstrations, such as the recent volocopter demonstration in Singapore. What we as a company did learn over the last few years is that UTM is extremely complex, and that's because of the size of the problem, the variety of applications, the variety of types of drones, and the variety of users, most of which do not have an aviation background. So it's a very complex problem. And what do we aviators do when we are facing a complex problem? We create a list, we create a checklist. That's how we work. So I have made my own personal checklist of functions that we already today provide in our product. And I would like to do that as a pilot, start of checklist. We provide a registry of drone pilots and operators, geo-awareness and geofencing, remote identification and EID, flight planning tools, flight validation using local legislation and all available data, automatic and manual flight approval processes, multi-authority flight approval support, strategic deconfliction, flight notification, dynamic low-level airspace management, flight tracking, visualization of manned and unmanned aviation, compliance monitoring, ground-based tactical deconfliction, incident reporting, incident analysis, and Asterix and AXM interfaces to ATM. End of checklist. In summary, we at Unifly have built quite a comprehensive product to help ANSPs and CAAs to manage the drone traffic in the airspace with a system that enables them to offer good services today, but which can grow in functionality and in scope to become a part of a distributed architecture as of when the interoperability standards will mature. The Unify product is, however, already available for operational use and can be demonstrated. And we have a live demonstration here at ICAO at our booth. Now, to complete the story that I started my conversation with, 6 months after my meeting with Peggy, she called me back. And she said, Mark, do you remember our meeting? Sure, I remember that. It seems you may have had a point. It seems we may have an emerging problem with drones. Could you please come back and give that presentation all over again? I did. And this time it was before the full board of executives at Skies. And to cut the long story short, today Skies have implemented a UTM at national scale using Unifly technology. Every commercial drone pilot in Belgium and every professional drone needs to be registered. Every flight approval and every waiver must pass through the system. The software provides a complete picture of situational awareness to all connected shareholders, the aviation authority, the air traffic controllers, the users, but also the local authorities. And in addition to Skies, other ANSPs are taking the necessary step and have taken the decision to work with Unifly technology. We have Naviair in Denmark, also Control in Austria, and the Deutsche Flugsicherung in Germany. And DFS is not only using our technology as the basis of their national UTM system, they also decided to invest in Unifly as a shareholder. And that's the end of my story. And now it is my pleasure to invite you all to a Unifly-sponsored lunch. And what is very well known about Belgium is that we enjoy food and we enjoy life. What I've ordered for lunch today is some of our favorite Belgian foods. Belgian fries, not French fries, Belgian fries. We have Flemish beef stew and Belgian waffles. Belgian waffles in Belgium are not eaten as breakfast, but as dessert. Thank you very much.
All right, thank you very much, Mark. Thank you to Unifly for lunch. Please be back at 1:45. So 13:45, we will start right on time. And I ask that the participants in the Trust Framework session come back a few minutes early, along with Frédéric Malot, who will take over as Master of Ceremonies. Thank you.